My name is Lance Smith. I am the CEO of Primary Data. We're splitting our presentation up between myself and David Flynn, co-founder and CTO of Primary Data. We'd like to go through some of the discussions that we've had most recently. We've done a few announcements here at VMworld. It's been a lot of fun. We want to talk about even the application of our technology. So let's get started. We've actually been talking about our product is called DataSphere. DataSphere, in fact, is a solution that we've created based on a technology that we refer to as data virtualization. Now, this data virtualization, our approach really is an abstraction layer that we brought into the data center that separates an application's logical view of its data from where it's located. The biggest benefit of that is that we're able to have a platform that dynamically, through an objective-driven environment, move data to the right place at the right time. There's a tremendous number of benefits that we have in our approach. First, we're storage agnostic. Our approach has helped to define what truly a software-defined storage platform needs to achieve. We've got to be able to work with all different types of storage from various different vendors, not just our own. The second thing is, for scalability and performance, we take the control path and we take it in-band for understanding where it's happening to files directly from a client, and out-of-band for the data path. So we don't get in the way of when a client needs to access the data itself. We need to ensure that it's actually able to utilize every different type of storage, whether it's a file-based or block or even object-based. This gives our customers options. Now, we offer it in two different forms, as a VM and also as a hardware appliance. Our customers are actually driving how we're actually creating and productizing this technology to market. The reason for the VM version, quite frankly, is ease of adoption and actually the ease of doing their POCs and trying the product out and deploying it into a virtualized environment. For the latter, it's the higher performance version. We're talking about high performance computing type of environments all the way at the high end, and people want the highest level performance. We implement it on a hardware appliance. Now, in either case, we offer it as a software subscription. So we actually offer it in two different forms. Now, our customers have come back to us and they said, look, don't try to limit us as to how many sizes of our files and the capacity that we've implemented in our data center. So don't hurt us because we have a small number of large files or a large number of small files. So we divvied it up into two different forms: 100 million file implementations and billion file implementations. And when customers want more, they can instantiate multiple copies and increase their total capacity. Now, this week at VMworld, we've announced that we've brought our product to market, and we're now actually entering our beta phase. We are focused in the enterprise space. So this is the more difficult areas to address mission-critical applications. We're first going after the test and dev applications within a variety of verticals. That includes oil and gas, media and entertainment, finance, EDA, health services. I'll talk about a few of our customers that we're engaged with today so you can get an idea of how they're applying their technology in their space.
What's the difference between measured performance between the virtual and the physical?
So it is, in fact, lower. It's probably a magnitude order difference between the two. But what we have found that in the VM version, when someone wants to actually have more performance, they can start to federate more to bring the performance up. But what we have found is that the activity here is the number of files that you're working with, like closing, actively opening, and closing. So when you get into the 30,000 or 100,000 operations per second, all we're worried about and focus is scaling the metadata and determining when and where a file is at and when we have to move them. So it turns out for enterprise applications, more than enough horsepower in the version of a VM. Of course, you can tune that to get more performance.
It correlates well also because in a virtual environment, you're often using very large files, VMDK files, so you don't have as fine-grained an access as you might have in a non-virtualized environment where you're dealing with more granular files. So it correlates very well that virtual environments don't have to be so fast on the metadata because you open the VMDK when you launch the VM and it stays open, so there is no metadata activity.
Okay. And I assume you're seeing people doing POCs with the VMs and then ordering appliances to go into production?
Well, interesting. That question poses what's happening with our customer base. Our customer is driving us on the VM side. So What's happening is that those customers want to keep it in the VM space because it's their ease of actually qualifying that platform. The financial sector is a good example. They flat out don't want the appliance to figure out how do they actually qualify a new piece of hardware, dealing with the security issues and so forth. They want the functionality, and they don't necessarily need the performance, as David mentioned. When you start dealing with a small number of large files, you don't need that kind of performance.
Right. Okay, thanks.
So our approach, as we mentioned before, is that we've actually separated the logical versus physical. And it's given us our ability to actually allow an application to continue running so that we can have data move from one storage type to another to achieve certain objectives that one wants to effectively achieve on the performance of those applications to deliver certain business demands dynamically. The second thing we've done is that separation of a control and data plane allows that mobility, but also allows us to use various different types of storages. Let me explain. When we look at the storage environment itself, we had to figure out a non-biased approach to figure out how do we place the different types of storage solutions. So what we did is we took, do they actually have to ship storage with their solution? So do they have proprietary storage, or is it storage agnostic? That's on one axis. The other axis is it an in-band solution? Is it a gateway? Do you have to pass through their proprietary system to get to the storage elements themselves? Or in fact, are they out of band for the highest level of performance? Majority of the companies that you may be thinking about, it's in the lower left-hand corner. Just lift open the lid. They may say they're software-defined storage, but in fact, they have either SSDs, they have rotating media of various types that are shipping. Up at the top, when you go into more storage agnostic solutions, these are more classic front ends or head ends that say maybe take a lot of small SANs and make them in one big large SAN. The advantage of going in the upper right-hand corner where primary data resides is in fact it allows us to be protocol independent, future-proofing for different types of storage that may come along. For us, it doesn't matter what and how the data is being stored. What matters to us is that it adheres to some type of standard protocol. This is the top-level view of how we virtualize our space using data virtualization. What we've got at the top, whether it be bare metal machines or virtual machines, and different types of applications that may or may not have some storage awareness. What we find is you have to configure these applications by hand. At Fusion.io, that's where a lot of us came from. When we invented this, putting a new storage tier within the server itself that was high performant, that actually could make an application run faster, it taught us that we had to configure those applications by hand and put the files that were most important to that app that were I/O bound to get more performance. When we learned that, and you had to configure it by hand, we had to figure out a way to create a global data space, which is what you see down at the bottom, of various different types of storage, so that we can move the appropriate data to the particular tier that have the best benefit. It could be the best economical benefit. It could be the best performance. It could be the best reliability or high availability. Those things get determined at a different place. At DataSphere, you can define objectives, smart objectives that actually drive whatever policies that the application needs to adhere to make sure that it's delivering on the business demands.
So in a nutshell, are you pretty much just creating a single pane of glass for storage with QoS?
It's a good question, and I'm going to give you an answer that's down that same line. What we're doing is we're giving one view from a data manager's perspective on how their application is running within their environment. So a data manager, those people worried about the application delivering on the business demand, can they see what requirements they have for the app, set their objectives for that app by file, all the way down to a single file granularity, full LUNs, subdirectories, and full directories, to make sure it's achieving whatever goals. Is it total number of transactions per second, total number of simultaneous users? And then on the opposite side of the coin, in the same graphical interface, is from the storage manager perspective, or the infrastructure side. They can look at their storage elements themselves, full standalone arrays, all flash arrays, and see if there's the good activity. If it's an expensive tier that's high performant, is the hot files there? If they're cooler files, don't keep them on expensive shared storage. Push them off to another storage type like an object store.
Are you in?
This is different than just rolling up the management into a single pane of glass,
Okay.
because it's actually the mechanics under the covers of virtualizing the data so that the data can reside in any type of storage with any connectivity under any protocol, and the application through this enhanced client is able to route the data path directly to it and refer to our control plane. So it's much more than just rolling up the management into a single pane of glass, because this is also about the routing of the data as it's being accessed, so that you have a continuity of identity of the data no matter what storage system it's in, and continuity of access even while it's moving between them. So this gets very intimate. It's a layer that sort of makes the data fluidly mobile around the infrastructure. So rolling it up into one management pane is only a nice side effect, or even one might say a necessity, once you've made it so the data is fluidly mobile across different types of storage, all the way from cloud, object, to direct attached flash. That full dynamic range is able to be addressed.
Are you doing your own metrics, or are you pulling it from the actual storage itself?
So the client that lives inside of the application server is actually reporting telemetry on what it's seeing. When you split the control path and the data path, it's really important to keep tabs on the data path and report it to the control path. And that's exactly what we've done with enhancing the standard NFS protocol to provide, for the first time ever, the needed feedback telemetry, so that we're actually watching what the application actually gets. Now, the cool thing about this is that then allows us to be topology aware. So it's not just that the storage system is capable of this performance, or that this storage system right now under load is actually delivering this performance. That alone is a big step from the first. But it's this storage system, the way it's networked and connected to this specific set of clients, is able to deliver to those clients this specific level of performance. That's taking a holistic approach that allows us to really monitor and guarantee the objectives, the performance objectives of the system.
So where's the profiling and the policy storage?
That's actually in the DataSphere itself.
Okay.
The points that Dave is making, that's done in real time. So we capture that telemetry, and that's the metadata for the files that are actually under management.
Now, when you capture, is that a split stream, or are you actually a true proxy go-between?
So we're not a go-between, because we split the data path off. So on the control path, yes, but except for we become the control path. So we're not a go-between there either. We take over the control path where it has all of the metadata, and we enhance the traditional file system metadata with the language of objectives and the service level catalog that the infrastructure is capable of, so that those two can be dynamically matched as they evolve separately, the physical evolving separate from physical. That control plane allows us to grow in sophistication, while in the data plane we route through the native protocol over the direct connectivity, fiber channel if it's fiber channel, direct attached if it's PCIe, great, SAS SATA, great, or off over the internet into the cloud. We're not a bump in the wire when it comes to the data path. The client, this universal client, we call the data portal. It's actually functionality that's built into the NFS protocol now. That data portal is what gives this splitting of control plane and data plane, and is able to route the data plane.
So once the client knows where a file's at, we're out of the way. That the client then gets to go directly to that for every access going forward.
So are you running an agent in the cloud itself, or are you doing the APIs to get
So when it
through?
comes to cloud connectivity, we have to be precise. If we're talking about cloud storage, or generally object storage, then our data movers, agents that help move data around the system, those movers can move data up to cloud and object storage and pull it down. And of course, we have all of the bells and whistles there with encryption, compression, dedupe, before you even send it, to minimize the amount of transactions. So it's a single instance store in the cloud that actually is up there.
What about the flip side, when it's actual virtual machines and such?
So when it's on the compute side of things, well, that's where the fact that DataSphere can be deployed as a virtual appliance comes into play. So you can instantiate us in the compute cloud.
Gotcha.
Right. Very good
Do you
questions.
need
Thank
an
you.
appliance in separate clusters? Does it matter as long as it sees the same storage
So
across clusters, or?
Because this is providing the mating of the logical to the physical, and mapping where the different data objects live based on their objectives, matching the service levels available in the infrastructure. At some point, you have to have a global view of all of the resources and a global view of all of the objects with their objectives. This is done through what's most similar to an exchange. I was going to into a stock exchange or an ECN, where it's negotiating what the different storage containers are worth to the demand of the objects who want to reside there to better meet their service level. So we're running sort of a barter system in miniature that allows the data objects to be inherently prioritized by which ones are willing to pay the most for the premium locations. This is using, an economic modeling to determine where it's best to place things. So that happens for the mapping of the data objects to the physical storage infrastructure. The namespaces can be divvied up, and you can serve different shares from different systems. So there's a part of it that's scalable. The front end that's serving file system ops is very, very scalable. The back end is scalable because it's running this simulation and an exchange model so that you can get concurrency even in that part of the system.
Going back to the virtual machine.
Hopefully that made sense. I don't know, because I think you're talking mainly about how to get concurrency and how to scale the throughput.
Yeah, right.
Yeah. The scaling the throughput of the namespace is done through multiple shares. Scaling of the actual resource allocation, a little trickier because it's an all-to-all problem. That's what I'm getting at. And if you have billions of objects and lots of storage assets, that's a huge, intersection. And the way we solve that conundrum is using the same way the industry does when it establishes the price of a stock, right? You have bids and asks, and the negotiation determines who's got the highest priority to be there, et cetera. Okay. Probably too much detail.
No, good.
No such thing at Tech Field Day.
Okay.
So for the virtual machine, are you limited by the hypervisor that can run? Can you do Hyper-V? Can you do VMware, Amazon, Google?
So the data portal is built into the most modern NFS client. Because we have on staff the Linux kernel maintainer of the NFS stack, maintainer of the SMB stack as well. So we've been able to enhance these things to have this data routing function that we need to do the look-aside on the control plane and then route the data natively. So in Linux, it's built in, which means KVM and all that comes for free. On Windows, there's actually two options. One is to have the data portal loaded as a filter driver, which helps redirect the data path before it even gets to the SMB client. The SMB still does the control plane, right? So we don't muck with all the sophistication in the control plane of SMB. We simply strip off the data and allow it to go direct to the target. So Windows Hyper-V is supported by virtue of that. And by the way, there's a fallback between those two, what we'd call native client data portal implementations. There's a third, which is where this is a service and can speak legacy NFS and legacy SMB or even CIFS protocols so that you don't even have to upgrade clients. But in that case, you are having to route through an intermediary this data portal as a service to get the portal into the global data space.
So we're first coming to market with an application in VMware, and then, as David mentioned, technically we actually can take this technology and this approach. We plan on going into all the four popular ones: VMware and Hyper-V and KVM and Xen. Over time, this will probably happen within the first year. Excuse me.
Xen is popular?
It's got a large footprint in the marketplace, and so we've had customers ask for it. May not be the first one to come out with, but it will happen in time.
But it's supported by default by supporting Linux. So
yeah, kind of comes for free.
Opportunity cost.
Yeah. Doesn't matter how popular it is. Your costs
previous
are down.
slides and sort of walk our way down. David, you don't have to sit down if you don't want. We started talking about, we're going to give him some time, hopefully, and get through some of these slides. Very good questions, though. Allows us to bounce around and answer them directly. The one thing I wanted to point out, we were talking about objectives, but there was an important part here that David was bringing up. There's objectives that you want to achieve with those applications, and then there's SLAs from the infrastructure side that has to be met to deliver those SLOs. So those objectives are interesting because you can have a catalog of those objectives, and that's what David was pointing out. Some may be invented in time as new services come online. For instance, let's see, we've had customers that is a top US bank in the financial sector that has a tremendous amount of SAN arrays that they've already deployed. And they want to have all flash arrays. Now they've got 10 petabytes worth of data sitting on the SANs, and they bought basically a petabyte worth of flash. Well, all the different departments are actually asking for that flash. Well, you can't take 10 pounds of data and shove it into a 1 petabyte bag, right? So you got to make some choices.
Isn't that
How
what
can you do
deduplication's
that?
for? Isn't that what deduplication's for?
Yeah, they might be using deduplication already on their storage system. So,
But there's data that doesn't need to belong there. Can you actually differentiate that? So the telemetry that we're catching on those files, we can distinguish that, and we can classify it and tell us you place it on those storage where it makes the most sense. So now the most important petabyte worth of information goes onto that storage tier and makes whatever the applications are at that time. It can change dynamically from day to day, putting that data on there when it's needed to get the most performance. It could be end of month, end of year type of back-end activity. They need it for 24 hours and then they're done. You don't have to dedicate it up front, and now you get to avoid the classic over-provisioning problems. Because it's a false economy to keep throwing more storage at it, because the primary store now gets too big.
So then what kind of reporting is in the product or business intelligence dashboards? How do we see what that
very
looks
next
like?
slide.
You guys are great. This one I didn't have to jump very far though. What we've done here is we've actually captured some views on the most left-hand side. I know it's a little hard to see, but I'll explain what's going on. The left side view is that data manager view. And is what we've ended up doing is we're actually able to show that it's specifically for one given application. In this case, it's Oracle. And then these lists down here are actually directories, subdirectories, and files that have been given very specific objectives. High performance or platinum, gold, bronze level. Is it archival? Is it log-based? And how that data is actually managed in real time to ensure that that application is meeting whatever its business demand is. You can see there's actually heat maps. You can see what files are actually utilized. That's what's basically being viewed by the application manager. And he can make decisions based on his budget. I want more flash. I want less flash. He doesn't know. All he translates it to is the type of performance. So he doesn't have to ask for certain gigabytes worth of flash. He can ask for certain levels of performance. In the middle, down at the lower side, that's actually the infrastructure or the IT organization point of view. What we list out here is all the different storage elements that they have. Specific types of storage arrays, or is it storage in the cloud? And you get to see the utilization of the capacity, the types of files, and whether they're hot or cold in nature. And if they're cold and they're on a high performance tier, you may now be able to go and analyze this, take those analytics and decide who's the offender. Who needs to be pushed off? Because the IT organization now needs to make sure that they're delivering on their SLOs. And if someone, let's say, has been, there's a VM that has now gone cold and the VMDK is sitting in its idle, maybe that person left or maybe that project is now finished, you can start moving those off of very expensive resources, but keep it online, right? Because we're in a global data space, because if that app becomes active again, then we can promote the file back up into higher performance tiers.
Go ahead.
Yeah, many questions about that bit. So,
Far away.
so you say it can be done. Is it automatic, or does it require human intervention?
This is where it gets to what I wanted to talk about.
Motioning
That was
itself
going to be
away.
my question. I was going to say,
No.
who
So-
decides what those
Yeah.
metrics
Right.
are?
That's
And how is it being moved?
There's a couple of different layers here that we have to go to. First is the data virtualization layer that makes data fluidly mobile. Once you have that, now the question becomes, how do you decide where something gets placed and when it gets moved? And that's what we talk about is the language of objectives that the data owner speaks versus service levels that are available, SLAs, in the infrastructure. So at the simplest point of view, those two things are negotiated. You find a service level agreement from the service catalog that meets the performance and protection objectives that have been classified on the data. And that is what determines where the data gets placed. That's a very simple view and would be completely unmanageable because nobody's going to go in and assign all of those to the different pieces of data. Right. But we have to start there because that's the foundation piece. The next level up from that are what we call smart objectives. Smart objectives are a way to express the conditions or pattern matching under which you should apply different basic objectives, the actual thresholds and target numbers. A smart objective could say things that are named, things that are in the /temp directory don't need any durability, but need this. Or a log file has the pattern matching to recognize what an Oracle log file is, needs this low latency write performance. So a smart objective
is that baked into the primary data appliance, or is that something that I have to define?
Yes,
Through a graphical user interface.
It's baked.
Well,
I
and
define it, or it's baked
and
in?
CLI. No, what we've done then is once you have this notion of a smart objective where the conditions and pattern matching can be expressed for how it should map over time. For example, a smart objective might say if it's been idle for a week, now it can be archived. Or if it's at a level of activity greater than 10,000 IOPS, then we need to promote it. So there's this language of, it's a predicate language where you declaratively say, here's the situation under which it should be treated this way. Those rules can all go together and are in a group that you can call a smart objective.
Cool. So who does that?
That can be pre-done even by us, so that,
We'll do a bunch of
or by a whole different class of people where they can build these smart objectives, make it easy to apply to an
That's
environment.
Who could do it? Who is going
So
to?
we will supply some to start with.
So there's some
All the
Make
basic
it very easy.
Okay.
Yes, that
So
make
there's
it very
sensible
easy.
defaults that come with it, and then the rest of it, I have to learn a predicate programming language to figure out how
No,
to
it's
do
a
that.
UI. You can go and say,
UI,
you can go and
test
say, look,
slides and set what you want.
I don't like that default that after a week it goes into the cloud. Let's make it so after 3 days it's already destaged to the cloud, right?
So when you get into time frames, what kind of time statistics do you hold on to? So for predictive monthly billing,
Yes.
or things like
So
that.
glad you asked that, because that's the third layer. So the first layer is the basic objectives, right? Second layer is smart objectives that are doing pattern matching. And the final layer is very sophisticated analytics of past history, which can then become part of the smart objectives. So this is where we are, because we're a dedicated control plane that's out of the data path, we can actually record the access history, the telemetry that's coming in from the clients on the individual files, store them with the files so that you can look at the fact that, oh my goodness, this file is never used except for on Tuesdays. And then it has a huge demand. So maybe we should put a smart objective on it that says on Tuesdays we elevate the performance level of the objective, and then on other days we don't need it.
Make that yearly, monthly.
So presumably
granularity.
right, the possibilities become endless at that point when you have the feedback loop of being able to take sophisticated analytics on the data and drive the objectives. By the way, this isn't just on performance, but it could be on security as well. And the analytics could be related to actually looking at what's being accessed in the file and who's being accessed.
So is it predicting behavior as well?
Yes.
Okay.
Yeah, by looking at the past history, it's able to do that. That's why we say this isn't tiering, and this isn't even caching.
So it's predictive
because caching
analysis.
is very reactive, right? Tiering is very coarse-grained and rudimentary. This allows you to do something very, very sophisticated in making sure the right data's in the right place at the right time.
Caching is just another form of over-provision, and you're sitting there duplicating the files, even if it's edge size, and you have 6 different global locations. You now got 6 copies of the data that you may or may not need. You got to sit there and figure out how to manage it, and God forbid you have to pin it manually to keep something in a cache.
Can you actually override those predictive measures?
Oh yeah, well remember, these are all, the analytics are at your fingertips for the construction of the smart objectives. So if you don't want to predicate it on that, you don't have to. If you would rather have a human in the loop, where you actually go and look at graphs of the thing and you manually build the schedule for when it's active, great, right? So has the ability to do the multiple layers of the onion of automation if you want, or peer into it to see how effective it's being at providing it for you.
I also want to point out that this information and how you decide what those objectives you want to achieve, you can limit something. You can say, I don't ever want, no matter how busy an application is and how many ops it's asking for, you can limit it to a specific storage type and have it never move from there. And let's say it achieves some other set of objectives over time.
So in other words, the objectives and the service level agreements are able to enforce caps so that you can shape the utilization of your limited resources, not just capacity, but also performance. And that's done at the client to actually make sure you're not stealing other people's performance with some application that doesn't deserve it, hasn't asked for it in the formal terms of objectives and the service levels that
You can
maps to.
tailor it on a per VM basis, a single application.
So that's a cap that I can set arbitrarily as like a quality of service.
Well, it's implied in the objective. The objective is the target. It could be a range, but it's a target range in performance, or a target point, right? If the app doesn't drive it, then that's okay. You're underutilizing the objective you've asked for. But if you go to overutilize it, and then the system can automatically restrain that performance consumption from an app that hasn't negotiated for it.
Yeah, because this links into something you said earlier that I wanted to ask about. So that's good that you can do that, because then I can act as an internal service provider and say, well, you haven't paid for that.
Because the real problem with this, and this is what we heard from customers, is the real problem is it's common for an app owner to be given something that is over-provisioned, and then they become addicted to it.
Yep.
And that limits the flexibility of the storage admin then swapping them out for something else underneath.
Yep.
So what we want to do is maintain that flexibility in the division between management of the physical infrastructure and management of the logical. So it's very important that the
So you're really
terms
trying
and
to
the
eliminate.
contracts that are negotiated are adhered to, even on the exceeding side. You don't want to exceed what was asked for, or else you lose the flexibility to retract it later.
So you really want to eliminate the storage guy's rule of pi for provisioning?
What's that? I'm not familiar.
However much the user asks for, you multiply by pi.
Not E?
No, pi's greater than e.
Pi's bigger. Yeah.
We've seen
like
it
the golden
actually.
ratio.
I also want to make go back to another point. I brought up one of David's slides because he did hint to this already. He mentioned we still watch what's happening between the app servers themselves and the data. This actually gets monitored in real time. So if something changes between the quality of service that data element is actually delivering, we can adopt and make a change. In the case of, let's say you've got a disaster recovery and you completely lose your primary store and you got to switch over, we can see that and we can do those switches and redirect an app new direction. But let's say that from a networking perspective, something happens between that application and that storage element. We can sense that and start making some changes so that we can continue to adhere to the service level objectives that have been set for that app.
This may be out of scope for what you do, but with that much insight into the file itself, and you're talking about things change. Now you're looking at a PCI capabilities and stuff. Can you get into that?
So let me take that even a step further, okay? Because we are speaking in a language of objectives that include measures of durability or persistence, if you have temp files, they don't require durability while the file's closed, right? So we can take it a level further and even map RAM at the client as part of the global data space into which the data could be placed that doesn't need that durability objective. So of course server local flash is going to have some level of persistence but not quite be as available, right? So it has a different level of availability and durability, or replicated between two peers gives you an even higher level of durability and availability. The system understands that. As a matter of fact, our data portal in conjunction with DataSphere can drive synchronous n-way mirroring. So you might not even have shared storage that's highly available, highly durable, and whatnot. And we can still replicate to peers those files that have the durability and availability requirements on them.
Do you have a limitation, distance limitation on your replication?
So this is a synchronous replication thing, but the system is inherently mapping the affinity of storage elements with the clients. So it understands the net impact of the topology on the performance delivered. And of course, to meet this performance service level objectives, it's not going to choose a storage element that isn't able to deliver to that specific client the level that's being asked for. In other words, what will happen inherently is that it will affinitize the data to the node using it and to a near partner. Now take this in contrast to other hyperconverged systems. By the way, this is a hyperconverged model inherently, right? Because once data is mobile, hyperconverged is just another topology, right? But other hyperconverged systems use block scattering, whether that's Scale I/O or vSAN. They all use a hash-based scatter, sophisticated hashing, so able to rehash so you can add and remove stuff, but it's still scattering
Calling
every block
vSAN
everywhere.
sophisticated is a big jump.
Sorry. The math is sophisticated. But the net result is that every participant gets the worst performance of the worst member. And
But they're all
every
treated
participant
equally, though.
Oh yeah, it's all equal. And every participant gets the worst reliability. If you have too many nodes go down, everybody's offline because everybody had something critical on the nodes that went down. So here we have the data affinitized. If I have slow nodes, they're slow serving themselves, right? They probably have a big CPU load, so they're not demanding as much. So it keeps the IO load and the CPU load localized and compatible, not scattering it. The same is true on a reliability front. If you have nodes go down in excess to your level of redundancy, more likely than not, the only files that are offline are the ones that were being consumed by those same nodes. So the other ones are still running because they're most likely holding their specific data sets locally. In other words, it's much better to sort the data out at the logical higher level. The higher semantic level keeps you localized for performance, keeps you localized for reliability.
Do you complement or mitigate SIOC? Or are you on a different plane than that?
SIOC.
Storage I/O control.
Because it sounds like you're doing kind of the same thing.
Yeah, I think without the data virtualization, SIOC is always going to be an incomplete solution.
I agree.
Yeah.
But I was just...
Yeah, so this takes SIOC to a new level because it can be used in the loop, actually directing the data migration around the system as needed. So yeah, we consider it a replacement of. Yeah.
What does it use to migrate the data?
Good question. So
How are we getting to these different...
one way to think of what we're doing is we're taking what's internal to the traditional storage array and turning it inside out. We're taking the metadata out. That's great. Now they can have continuity of identity even as the data is placed on different storage systems. Right now the identity is trapped in with it. So when I move something to another silo, it's a different identity. It's a different piece of data with a different name. So by pulling the metadata out, that's the first step. Pulling the routing function up to the initiator, so we don't have to have all these bumps in the wire rerouting it like in a scale-out NAS environment with extra layers of boxes. So we pull the routing function out. Normally inside the box is where it routes to the different tiers, right? But then you have to go off of the server over to here just to have them route it. And it'd be really stupid to have them route it back to you. Going here, just have them route it back. So by pulling the routing function up here as a collaborative lookup effort, he's resolving where it's located. Once it's resolved, then he can go natively. It's kind of like DNS. Can you imagine how stupid it would be if the DNS server that looked up Google for you had to proxy all of your subsequent traffic to Google? That's how broken NAS is today. The thing that opens foo has to subsequently pass all the traffic to foo. We fixed that. That's what the splitting of the control plane actually is. And that's done with this more sophisticated client built into the NFS protocol with our data portal technology. It does the look-aside lookup and then routes directly. So that's the second piece of the SAN or NAS system that's turned inside out, the routing function. It's moved forward. That allows you to route it direct attached or even to in-server memory. That's the second piece. The third piece is the data moving, the things that actually is moving data around as it needs to repack stuff. And that for us is an agent that can run anywhere in the networks deployed as software or a dedicated appliance if you want. It's built onto all of our appliances as so it can pump data. We call it our data movers. Those data movers can exist anywhere, including in a virtual machine alongside your other virtual machines or wherever. You want to place it strategically within the infrastructure where it has available the access performance that it needs to do the moving. But by virtue of the telemetry feedback, we understand the net impact of the topology on the performance of the data movers.
So we should point out one thing. When we're moving data, it's still accessible. So we don't stop the application, one, to say where the file is at. Two, while it's in flight, it can still perform its IOs to that same
So
file.
your appliance is actually moving the data within
These
how-
agents,
how
the data
scalable
mover
is it in a
agents are
geographic
doing that.
environment?
And they're not even, DataSphere has data movers on it, but that would kind of be your last resort because he's serving metadata transactions. If the data movers can live in virtual machines or physical machines on the data stores where we can put the software, so it can live in the network wherever. And we actually use Salt and other orchestration engine to be able to manage these agents throughout. That's what it takes to turn the storage array inside out so that it becomes a passive repository of data, no longer holding the identity and metadata, data moving and routing hostage.
So,
David, there was a question of scalability.
Yeah, scalability from multiple data centers geographically. Let's say you have a data center
So-
in the U.S., UK, India.
So our initial
How does that
product
work?
is going to be targeted towards single data center with another data center as a sort of a passive offsite for replication for DR. The next generation product will support data center to data center federation, at which point all the stuff we're talking about here with affinitizing the data to where it's being used on a more micro scale to server flash versus on a storage system. You might have a flash appliance that's top of the rack and has much better bandwidth to the nodes inside that rack. So this same pattern of affinity happens at multiple layers out. Flash in the server to the server, flash in the rack to things in the rack, arrays in the data center to things in that data center, or things across foreign data centers. For us, those are all the same. It's the same problem repeated. It's all about what is the proximity as expressed in the net impact on delivered performance, which we monitor.
Could you do something with the cloud?
We do operate with the cloud in the sense that cloud is one of the pools of storage, or more precisely, object storage over S3 or Swift or Azure is available as one of the pools of storage you can add into the global data space. And then when the objectives on the data necessitate or allow for the data to be placed in the cloud as opposed to needing something more expensive, then it might be demoted into the cloud, or it might be placed into the cloud so as to meet a disaster recovery objective. It's actually interesting to note that the cloud actually has two functions. An overflow cheaper area where you might stuff something to free up local space, that's kind of a demotion scenario, or you put it in the cloud so as to achieve a higher level of disaster recoverability from it. So that
I do want to point out, when it does get pushed out into the cloud, it doesn't go offline. It's still part of the global data space. So when the application wants to make access to it, I mean, it can promote it back up.
So if my data center blows up and
then you have it.
we can
As a
still
matter of
run
fact,
if it's in the cloud.
this is an important thing to recognize. When we talk about placing data, it's not where the data gets placed, it's where all the data gets placed. Because a given piece of data may be placed on multiple storage systems to achieve a composite or aggregate set of service level objectives. It might need to go on multiple systems to get better availability, better reliability. It might need to be off in the cloud to get disaster recoverability, and might need to be local to get some level of performance. Of course, you can construct a service level objectives that are not achievable with the infrastructure. For example, if you ask for off-site recoverability and high write performance, or really any write performance, it's going to say can't do those two things unless you allow for a recovery point.
Right.
It's not zero, right?
So that'd be more high availability rather than
That's right.
disaster recovery.
Right, but these are all on the,
Staying
these
up
are
all
all
the
on the
time.
same spectrum in the sense that high availability is a synchronous RPO0 replication. The other one is an asynchronous. It has some time window before it has to get replicated up into the cloud.
Okay, that might have answered my question then, but I'm going to just ask for a little more clarification. So she had mentioned like the global data centers, and you said that you are only looking to initially focus on like
The initial one we're because we want.
So what's the limiting factor there? Why can't you do global as opposed?
Just because we haven't implemented it yet. It's just a time to market.
Okay.
Because in the future, what we will have is the data spheres will be able to work federated. So you can have DataSphere in one data center, DataSphere in another data center. They work together to serve the data space in their respective data centers and make
then-
it look as a global namespace, as
So
one
We should
global
probably clarify one thing. Let me just real quick. Our strategy is to have those data spheres closest to the applications of the end users. We don't need to be near the storage. The data movers need to be near the storage between each one of the storage. But for us, the measure of performance and capability is really the control panel path, not the data path.
So you'd need DataSphere
Yeah,
in
but
each data center working.
it's
in a
got to
federated-
be roughly co-resident. You don't want 100 milliseconds of latency for a metadata lookup.
That's
Exactly.
That's right.
That's exactly
That's
the
right.
point.
You-
That's why we
exactly
keep
the
it
point.
close to the clients.
But when you get to the point where you do geographical affinity, that opens some really interesting
Absolutely.
tie-ins to
Absolutely.
metro clustering.
Well,
Right.
because you can move the data
This might be-
while it's in
Yeah,
use.
follow the sun.
But
Well, you have to. Well, it's the
Well, how do you handle
scheduling,
compliancy?
the moving of the storage and the compute
across.
across that. We can move either one, but
a
saying
cruel-
move them both and
it's a
get the
cruel,
timing
cruel
right.
irony that workloads that are HPC-like or technical computing using Linux clusters, they tend to use NAS as their storage, and yet when you go up into the public cloud, which would seem to be the best place to overflow a rendering job or an EDA job, you don't have access to your shared file space.
Right.
You don't have access to it because it's not connected as a global space. Recently, you can at least get shared file in the cloud from Amazon anyway, but you don't have your shared files in the
Right.
cloud without this. So this solves the issue of how do you extend into the compute cloud these technical computing types of jobs that
And this is a thing that I need to clarify because maybe you've said it and I missed it. But so in the data path you can move things from say file to block, object, cloud. Okay.
exactly.
So this is kind of magical. The final thing of I just have some storage.
And yes, that's exactly right. And the way we do that is the data portal. It's a universal
you do need
client.
some fast storage or some cheap storage.
I need to buy some
have to have
physical
the storage.
hardware.
But
to
we don't
start
care.
with,
We're
but now I can
agnostic.
finally
Who's
have.
ours?
I just want some storage.
Right.
And
Storage has some kind of
we take
attribute,
file,
right?
block, and object. To be really precise, we take file, block, and object, and we elevate its control plane to have all the sophistication of file. So you don't have these ethereal LUNs that are floating off in the ether that they actually show up as a node in a namespace where you can look in a directory and see them, right? So you can manage using the sophistication of a file namespace, even your block LUNs, right? So we elevate file, block, and object to file, and then it can be expressed at the client as file, block, or object. So it's file, block, or object on file, block, of object with the manageability of file across the board.
It was extremely cool. So
Thank you.
I'm an enterprise, which is a client you want because they have lots of money. I already have stuff.
Yes.
How do I start using your thing?
Haha. Very good. Very good. If it's NAS, it's actually really easy. We can assimilate the NAS metadata and data instantly. We don't have to copy it, any of it, up front. So you can simply point DataSphere at this, and then with tripping over the clients to point there, we can immediately start serving the share that was on that NAS system. Now the cool thing about that is that as soon as you do that, now that data becomes fluidly mobile across the rest of the infrastructure. So if I want to upgrade to cluster mode, a bunch of 7-mode NetApps, right now it's a fiasco because they have to copy the data off basically and copy it back, and your application is down. Here, I just have to restart the clients pointing at this guy who's set to assimilate that, and
So it is, okay, so I have to take an outage with my client, which is a drag, but
we have to do that, yes. We actually thought about maintaining the continuity of file handles and all of that, and it's better just to say, take it down once, and then call it good.
yeah. So
That way we can replace the file handles with file handles that we give, yeah.
So it's the data mover component that needs to go in close to the app servers and so on. Yeah.
Actually, the data mover doesn't have to move, well, the data mover doesn't have to move it for us to start serving it in situ.
No, I mean,
because we simply take those files, and we doubly link them into our object structure, and then after it's all assimilated, you can remove the old directory metadata structure, and you're just left with the objects and the metadata over here.
No, I mean, I meant
It does the metadata
Yeah.
pull over on demand.
Yeah, so
So it can start serving the root directory, and any subdirectory you go into, it pulls over as it needs it.
So the primary data component needs to go in next to the client in order to be able to do this. And it gets to get injected into the control and data.
Well, it's built into the client. Let's be really clear. It's built into the Linux client. It's built into as enhancements of the PNFS, the NFS 4.2.
Yeah.
So we've made sure that everything is standards and open in the client.
Okay.
And it's upstream. It's already in because it's the Linux kernel maintainer who's the gatekeeper on that, who's built it. So
my
that means
application that needs some data needs to I need to reboot that to have a component installed in it.
Yeah, if I'm already running a specific version of the OS here and whatnot, you can load the new NFS Client RPM here, and voila, you have it. You don't have to upgrade the OS because the new NFS client will live inside of all of the broadly deployed existing Linux kernels, and it's all open source.
Okay,
so yes, you have to have that new client, except for you don't, because the data portal can be deployed as a service that speaks old NFS or old SMB and CIFS. So for a transition time, you could go through an intermediary that does the translation for you.
Okay.
That will, of course, not unlock the performance potential of going direct, but it gives you the ability to smoothly
help get me there. Yeah.
Right.
And block is as well, and different. So what are the kinds of clients that you support? So
the PNFS client supports routing things natively over block, whether that's fiber channel attached block or direct attached local stuff.
Right, but data that's on blocks can require a movement into your file system on block, right?
We can move transparently the data from file to block or from block to file.
Right, but if I have a VNX that's full of data, for you to manage it, I need to copy it.
Yeah, because we don't necessarily know what kind of file system you've overlaid on it and all that other mess.
Yeah.
So yeah, it's not as easy with block. Yeah.
Not objecting, just clarifying.
Well, that's why block is such a bigger pain in the ass to manage, right? I mean, because
hey, look, we're storage guys. We have to make a living somehow.
Exactly.
I thought you just surfed the internet.
So yeah, you are, but I'm
You
dealing,
know me
I'm
too
dealing
well.
more with the CFO who wants to know how to do this. So so I'm looking at the applications that I've got. So let's say I've got, say, an Oracle database that's running on, maybe it's on a VM, maybe it's on physical, something like that. Can I use your stuff with that?
With an Oracle, absolutely.
Yeah, so I've got Oracle and I've got a whole bunch of LUNs, and the DBAs wanted particular layouts and stuff because.
And I'm sure when we get further into the block stuff, we'll set it up so you can assimilate a LUN in place. It'll show up as a file in the namespace, which then can be loop back mounted and exported as a block device to the app. So it'll actually be rather interesting because the Oracle database will be consuming block that is internally a file expressed as block. That file, its control plane is being served from here, but when it actually goes out on the data, it's going out block. So it's accessed as block, and it comes out of the box as block, but internally, the nice little sleight of hand, we've added the control plane in that lets us manage that LUN as a file in the namespace. And it allows us to migrate that logical LUN into a file on a NAS system or off into the cloud, or put the LUN along with a bunch of other LUNs in the same SAN. If you were to go look at the SAN though, what you see is there's really just one big LUN, and that's just using some of the space in it.
So now you say that. What do you say for applications that, let's say, need to be on block storage and not NFS based? If you're faking it,
so they will consume it as block, and when they access it, they'll access it as block. And if the SLA or the objectives that map to the SLAs require fast fail and other features that only SAN provides, then the data will only be in compliance with those objectives when it's on the SAN storage. In other words, we're letting you express things like fast fail and whatnot that SAN provides in an abstract language of objectives, and those objectives can drive the placement of the data, which can be monitored by watching compliance or non-compliance of the data to its stated objectives.
So while we have a few minutes left, there is another announcement we made this week. This technology, we've applied it in the compute virtualized space. With the new release of vSphere 6 and the upgrades to Vasa, we basically take this same approach, and I'll let David talk about the technical implementations of it, but the bottom line is this. We're able to support vVols and able to have that two-way communication about achieving those objective levels. But here's the important part. We can take your existing storage and make it vVol capable.
So,
Exactly.
so in other words, we can take all of
It's
your
okay,
legacy
Justin, you'll
storage.
get over it.
And there's like $300 billion of already deployed storage supporting virtual environments. A good proportion of that may never support vVols.
I think that's the existence of storage today, according to IDC.
Sorry.
So we can make that vVol capable. I think.
Yeah.
So your application aware storage management.
That's a good way to put it. That's one way to put it. Even that downplays it a bit.
Some
because,
storage.
Yeah, it's not just
Right,
managing
yes.
the storage. It's splitting the management of storage from the management of data. So now you have a language
Look,
for
it's
talking
actually
about it.
software-defined storage.
This is the real software-defined storage.
In the software-defined
Well,
network.
Right.
Because we're the overlay control plane.
Right, in the software-defined networking
Agnostic
definition.
to the storage.
Yeah. It's
Again,
like-
achieves the two attributes that are important, we think, for software-defined storage. Work with any kind of storage, right?
Deployable as software.
Keep out of band, right? Deploy software is, an obvious
Third.
one.
But the performance is still based on what type.
That's right.
Yeah.
It's whatever investments you've made in the
Right.
type of storage.
Yeah.
There's no overhead from us, right? So if it's a low latency storage type, you'll get that low latency. If it's high capacity to low cost, you get that. We're not in the way.
That's why this is so revolutionary compared to something like SVC that sits in front of SANs to make a bigger SAN, or scale out NAS, or a Copia that tries to make a bigger NAS from lots of smaller NAS. Those all sat in band, and they slowed down the access and made it a nightmare. This, by serving it on the side, we're able to overlay a much more sophisticated control plane without impacting the data.
It's amazing, but not magic.
No, there's an explanation for how it's done. It just hasn't been done yet.
Pagan magic.
The reason why it hasn't been done yet is because it's very ambitious to go in and make this universal storage client. And it's something that the incumbent storage vendors have not been very incented to do because they benefit from the siloed state of affairs. It keeps,
That is your weak spot, basically, because you have to write clients for every...
but those are all standards. Fiber channel SCSI is standard.
proprietary based.
NFS is standard. It just needed to
You
get
cannot run the NFS 4.2 inside of an ESXi host, right?
exactly. So we're not going to wait for them to do it. We're going to go and make sure we have the technologies in place where we can speak to these in a universal way. So it
Yeah, but
doesn't matter.
I can imagine that limits you because each and every client has different limitations, different restrictions, causing like a very, very difficult image of what a client can do, what exactly.
Not sure which dimension you're talking about.
in what way do you mean? Yeah, because I'm not.
So each different protocol has different limitations,
Yes.
and you have to work around that.
But largely
basically.
there's only really two. Well, there's three. If you consider there's SCSI
Yeah.
and FC block and NAS, right? Really only NFS 3 on up is used. 3 is very common, right? Those are really the two, other than within the OS there's the virtual file system layer where you're exposing potentially server local media, their internal block layer and their internal file layer. So our universal client can consume all four of those: block, file,
Without any-
local on the VFS, or block, file, remote over the network, plus the cloud. And those, remember, those have to be very, very clean, and otherwise they wouldn't be cross OS and cross application. So, it's very doable. Just nobody's bothered to put that intermediary layer of software to manage this routing. And Flash has really been the catalyst for this. If you think about it, and this is what happened when I founded Fusion.io. I'm a software guy, and I'd been doing HPC, working with huge parallel file systems and big Linux clusters. And I saw what Flash could potentially do, and I said, this is going to change enterprise storage from a siloed, centralized mainframe model to a model where you have to distribute the data. But if you have to distribute the data, how on earth are you going to manage that unless you virtualize it and abstract where it lives at any point in time? So this is this is driven by Flash forcing a distributed architecture to tap into the low-cost performance. Little did I know that cloud was going to drive the exact same distributed architecture on the cheap capacity side. Commodity servers scaled out as an object store. You will never address in these traditional storage silos the dynamic range that you can get with server local non-volatile memories and with cloud and object storage. So the silo is dead. We have to have data exist beyond the silo. And that's what the data virtualization is really doing.
So I think we're basically at the end of our time slot. Hopefully we've been able to answer many of your questions. Continue to tweet the questions, and then we'll do our best to try and respond to the subsequent ideas or even implementations of our product in different environments. So we really thank you for your time.
I got one more that's non-technical.
Okay.
Since you're being revolutionary, how are you going about convincing people that your way is better?
So the easy way is by being able to go into the market in a slipstream. This is where the vVol support is so powerful, because people are looking, how do I upgrade to vSphere 6 with VASA 2? And with us, that becomes easy. They don't have to upgrade their storage. They don't have to mess with that. So we're actually allow a net gain on the install. So we're not asking somebody to go to the extra pain of installing us. It's like, use us to make that pain less.
Very good.
Yeah.
Much less. The same
leave
is
you
true
with
with the
two more
cluster.
thoughts.
The same is true with upgrading to cluster mode on NetApp. Like if NetApp's forcing you to go to cluster mode, let us help you with that. So your data migration, all that, isn't so painful.
I'll leave you with two more thoughts. The first is we use what you've got. So we don't force a forklift event. The customers that we talk to, the first question is, are you selling storage? The answer is no, and they grin from ear to ear. That's the first one. So it makes it easy to adopt the technology and make more use of
If
it.
you were selling storage, then they would decide to buy from you, and the EMC guy would take the CIO out for golf, and they wouldn't get what they want.
Yeah, but it's kind of hard for them to argue we want to keep the silo. We want to keep it so the data can't
Yeah,
be...
the EMC salesman's happy he gets to sell support on that VMX.
And that's the beautiful thing is anybody who is trying to crack into these siloed storage areas has a reason of partnership with us, because we allow the data then to become
Sit
fluid
right
and
next
mobile
to it.
out.
You can have different vendors, right? So that flexibility is what the customers are looking for. And when we show them how they can put data in the right place at the right time with the right data, that is a big, powerful story for them. And I have to tell you, the customers come back and it's unanimous. They all want to deal with this technology and bring it into their environment and make their life simpler and get that over provisioning down so they can actually extend their budgets.